Hi everyone, this is Sir John from Cainta Senior High School. Welcome to our lesson today about the differentiation rules. Let's start. So at the end of the lesson, the learner shall be able to, first is to learn the different notation of differentiation and apply the differentiation rules in computing the derivative of an algebraic, exponential, logarithmic, and trigonometric function. But before we dig in differentiation proper, let me introduce the notation of differentiation. Because this is often the most difficult, confusing thing for a student. How do we write differentiation? How do we represent it? That's the question. So one type of notation for the derivatives is sometimes called the prime notation. So this function, which would be read f prime of x, means the derivative of f of x with respect to x. A second type of notation for derivatives is sometimes called the operator notation. So the operator dx is applied to a function in order to perform differentiation. And another commonly used notation, it was developed by Leibniz and is accordingly called the Leibniz notation. So with this notation, if y equals f of x, then the derivative of y with respect to x can be written as dy dx, not dy over dx. Clear? Okay. How do we find the derivatives? So the procedure for finding the exact derivative directly from a formula of the function without having to use graphical methods is called the differential calculus. So in practice, we use some rules that tell us how to find derivative of almost any function. So in this lesson, we will introduce these rules. Okay? But before I discuss these rules, let's compute the derivative of this function, 3x squared plus 4. Okay? Using the limit definition. And this limit has been discussed from the previous lesson. All right? So again, we are to compute the derivative of this function f of x equals 3x squared plus 4. But let's first recall the definition of the derivative of a function, and it is given by f prime of x equals the limit of f x plus h minus f of x over h as h approaches 0, no? If the limit exists. Now, to start solving with this problem using the limit definition, let's work out with our numerator first. So our numerator, okay, equals 3 times x plus h squared plus 4. Where does this come from? From this. We have to substitute this one to our x squared plus 4 minus our function. What's our function? F of x. 3x squared plus 4. And by expanding x plus h squared multiplied by 3 will give us 3x squared plus 6xh plus 3h squared plus 4 minus the same, 3x squared plus 4. And combining all terms, like terms, 3x squared minus 3x squared cancels out. Also, 4 minus 4 cancels out. What's left is the 6xh plus 3h squared. Now we can factor this, factoring common factor, that is h, that's a common factor. H times 6x plus 3h. So this is our answer for our numerator. So we can directly plug in our answer to the numerator. Okay, so this now is our numerator over h. H cancels out. What's left is 6x plus 3h, and then applying the limits, h approaches 0, so h is 0. The answer now is 6x. Okay, did you get it? So you see that computing the derivative using the definition of even a simple polynomial function, it's a lengthy process, so long. So what follows next are rules that will enable us to find derivatives easily. We call them differentiation rules. Okay? And for the first rule, rule number one, the constant rule. So it says that if f of x equals c, where c is a constant, then f prime of x, the derivative of the function, equals 0. So the derivative of a constant is equal to 0. So here, in rule number one, we're not gonna use the limit definition, for it will consume our time. Okay? Just follow the rule. My son. Okay. See you later. Go down now. Thank you. Okay. So again, we're not going to use the limit definition here. It's time consuming. Let's just follow the rule. If you're looking for the derivative of a constant, then automatically the answer is 0. Let's have an example. Bye, Jacob. Okay, number one. If f of x equals 9, then the derivative of the function is 0. Simply 9 is constant. That's it. Number two, if g of x is equal to negative root 7, then g prime of x equals 0 because this is constant. And number three, if h of x is equal to 4 pi, then h prime x, the derivative, it means derivative, equals 0. So all the derivatives of constant is always 0. Is that clear? Let's move on. Number two, rule number two, the power rule. It says that if f of x equals x power n, where n is the element of natural numbers, then the derivative of the function equals n times x power n minus 1. Question, what are the natural numbers? Okay, natural numbers start with 1, 2, 3, 4, and so on. Right? So n could be 1, 2, 3, 4, 5, and so on. Let's have an example. Number one, if the function f of x equals x cubed, then the derivative of the function equals, so if we follow this one, let's bring down the n here, our exponent, and 3 times x power, your exponent less 1, will give you 3x squared. So the answer, the derivative of this function x cubed, is 3x squared. Number two, if g of x equals 1 over x squared, then g prime x equals, the first thing is to convert this term into a negative exponent that will look like this, x power negative 2, right? You convert it to like this, and then you have now your exponent. Bring it down here, will give you negative 2x. Now negative 2 minus 1 will give you a negative 3. So negative 2x, negative 3, and then change again from negative exponent to positive exponent, just put it down, will give you negative 2 over x power 3. It is now positive 3. From negative 3, put it down, it will become positive 3. Final answer, negative 2 over x cubed. And number 3, if h of x equals root of x, then the derivative of the function equals, again, we change our problem into exponential form, like in number 2, in exponential form. So that, since our rule is a power rule, so change it to exponential. So this thing will become x power 1 half. Then 1 half will go down here. That gives you 1 over 2 times x power 1 half less 1. Always less 1. Okay? So what is 1 half minus 1? Okay, 1 half minus 1 equals negative 1 half. So our answer is 1 half x power negative 1 half. To make this one positive, just bring it down. To make your negative exponent positive, just bring it down. And that is equal to 1 over 2 x power 1 half. But we change it into radical form, from exponential form to radical form. So This is our final answer. 1 over 2 root of x. Is that clear? Next. Rule number 3. Okay, rule number 3 is the constant multiple rule. Okay. It says that if the function of x equals k h of x, where k is a constant, then the derivative of that function is simply k, the constant, multiplied by the derivative of the function h of x. Again, this will be the answer. The constant multiply the derivative of your function. Let's have an example. Find the derivative of the following functions. And our number 1 is 5x to the 4th power. Then the derivative of that function is simply constant, that's a constant, multiply by the derivative of x power 4. This is power rule. How to solve a problem in power rule. So 4x, 4 less 1 will give us 4 times 5, 20, x power 3. So this is our answer. Number 2, g of x is equal to 2 root x. Then the derivative of that, again, you have the constant. Simply multiply the constant by the derivative of root of x. But we change again the root into exponential form. Will give you x power 1/2. And then x power 1/2, if you find the derivative of this, will give you 1/2 times x power 1/2 less 1 from our previous rule, the power rule. What's next? So 2 times 1/2 cancels out, or simply 1 times x power 1/2 minus 1. 1/2 minus 1 is negative 1/2. So negative exponent is unacceptable as a final answer. So we have to change it into 1 over x power 1/2. And 1 over x power 1/2 is simply root of x. Okay, the x power 1/2 here in the denominator will become root of x. So this is our final answer, 1 over root x. Okay, next is rule number 4, the sum rule. And it says that if f of x is equal to g of x plus h of x, where g and h are differentiable functions, then the derivative of the function is simply the derivative of the two functions, separately. Derivative of g function and derivative of the h function. Let's have an example. If our function g is 5x power 4 and h of x is equal to 2 root x, differentiate g of x plus h of x. So separately derive or differentiate this one and differentiate this one. The derivative of g of x is 20x power 3. Why? Y becomes 20x power 3. 4 times 5 is 20x. 4 minus 1, that is 3. So 4 times 5 is 20, x power 3. That gives us 20x power 3. And then x or h prime of x is equal to 1 over root of x. So here, change again. It's a constant multiple. Constant times this one. Change into an exponential power. Derivative of this will give us 1 over root of x. And then add the 2. 20x cubed plus 1 over root x. Can we simplify this? I don't think so. So this is our final answer. Number 5, or rule number 5, the product rule. It says that if f of x and g of x are differentiable functions, then the derivative of f of x times g of x times equals the first function times derivative of the second function plus the second function times the derivative of the first function. I'll repeat. First times the derivative of the second plus second times the derivative of the first. Okay, let's have an example. Find the derivative of x if find the derivative of your function if our function is equal to this, 3x squared minus 4 times x squared minus 3x. Okay, let's do it. Okay, our first times the derivative of our second plus our second times the derivative of our first. So let's just copy our first here, and then the derivative of our second will give us 2x, right? 2x minus 3 plus our second, this is our second, times the derivative of our first. The derivative of 3x squared minus 4 is 6x. And then do the FOIL method here. It will give you what? 6. I think this is the final answer. No? Just manipulate using your algebra knowledge. Okay, FOIL and then combining like terms will give you 6x cubed minus 9x squared minus 8x plus 12 plus 6x cubed minus 18x squared. Okay. Oh, correction. When you multiply this first terms, will give you 6x cubed. When you multiply this and 3, will give you negative 9x squared. When you multiply this and this, will give you negative 8x. And negative 4, negative 3 will give you positive 12. And on this side, 6x times x squared, that is 6x cubed. 6x minus 3x, that will give you negative 18x squared. Combining like terms, the x squared, combine it. The x cubed, combine it. Okay, that will give you 12x cubed minus 27x cubed. Oh, my correction. This is not, wait, this and this, 12x cubed. Okay, and then 9 and 18. Oh, correction, this is not cube. X squared. That's corrected. This is x squared. All right. Minus 8x. This is our 8x plus 12. So our final answer is 12x cubed minus 27x squared minus 8x plus 12. All right. Rule number 6. The quotient rule. The quotient rule says that if f of x and g of x are differentiable functions with g of x not equal to 0, then, okay, the derivative of the first or the numerator function over denominator function equals, this is how you do it. You just raise your denominator into a power of 2 for your denominator, and then for your numerator, denominator times the derivative of numerator minus numerator times the derivative of denominator. Okay, let's start. Example, find the derivative of this function, 3x plus 5 over x squared plus 4. So first, your denominator, raise it to a power of 2. Okay? And then in our numerator, it says here denominator, x squared plus 4. Denominator times the derivative of our numerator, which is 3. The derivative of this is 3. Less our numerator, this is our numerator, times the derivative of denominator, and that is 2x. So when we distribute this, multiply, okay, 3x squared plus 12 minus 6x squared minus 10x over the square of x squared plus 4. So combining like terms again, 3x squared minus 6x squared, that is negative 3x squared, 12 remain, negative 10x remain over the square of x squared plus 4. So this is our final answer. Next, okay, for rule number 7 is the derivatives of trigonometric functions. So in this rule, you just need to try to memorize all the derivatives of these 6 trigonometric functions. We cannot, or I will not prove this, for it will take much of our time to prove that the derivative of sine x equal to cosine x using the limit definition. That is time consuming. So just remember that the derivative of sine x is cosine x. Derivative of cosine x is negative sine x. Derivative of tangent x is secant squared x. The derivative of cotangent x is negative cosecant squared x. Derivative of cos of secant x is secant x tangent x, and the derivative of cosecant x is equal to negative cosecant x cotangent x. Let's Let's have an example. Find the derivative of f of x if your function is secant x plus 3 cosecant x. So separately, we have to find the derivative of this term and another term. So the derivative of secant x, you look at your table. Derivative of secant x is sec x tan x. That's the answer. Plus 3 cosecant. The derivative of cosecant x is this. Negative cosecant x cotangent x. So this is our derivative. Multiply by a constant. So our final answer will be sec x tan x less, because you multiply a positive and negative, less 3 times cosecant x cotangent x. That is our final answer. Okay. And next rule is the derivative, or rule number 8, derivative of an exponential function. So another notation of differentiation, ddx. Remember the ddx? It's the same. Finding the derivative of e power x, finding the derivative of e power u. So what's the derivative of e to the x? It's simply e to the x. Okay. How about the derivative of e to the u? So the answer there is e to the u, derivative of u. Whatever function you have in your u, find the derivative of it. Let's say, for example, number 1, find the derivative of 3ex. 3e to the x. So the derivative of 3 to the x is simply 3, the constant, times the derivative of your e to the x. And what is the derivative of e to the x? This is our answer. The derivative of e to the x is simply e to the x. So the final answer is 3 e to the x. Okay. Number 2, find the derivative of e to the 4x. E to the 4x. So the derivative of e to the 4x is equal to, okay, e to the 4x, derivative of u. What is our u? This is our u, 4x. Okay. This example number 2 falls in this rule. Okay. So again, e to the u, just copy e to the u, e to the 4x. Then derivative of u. What is our u? 4x. Derivative of 4x. What's the derivative of 4x? That is 4. Okay. So 4 times this term will give you the final answer, 4e to the 4x. All right. That's our final answer. Okay. Another rule of derivative of an logarithmic function. We have derivative of ln of x, or ln of x, equals 1 over x. This is our answer, always. For ln of x, or ln of x, the answer is 1 over x. About derivative of ln of f of x, you have the function here now, because the function here is just x. Here you have a certain function now. The ln of f of x will give you 1 over the function, copy the function, times the derivative of your function. Let's have an example. Oh, the log. This is natural log, and this is log with the base a. Okay. Derivative of log x with the base a is simply 1 over x ln of a. Okay. X, just copy your x, and then ln of a, whatever base you have, just copy it. If it's base 5, 6, 7, or 10, that is your a. And then the derivative of log of a function, base a, will give you 1 over, just copy the function, ln of a times the derivative of your function, f of x. Okay, let's have example number 1. Find the derivative of ln x squared. Ln x squared. So this one will fall here in this rule. So the derivative of ln x squared is simply 1 over the function here, 1 over the function, our function is x squared, 1 over the function times the derivative of the function, and our function is x squared. The derivative of this is 2x. So 2x times 1 over x squared will give you 2 over x, because x, 1x cancels out. 2 over x is our final answer. Example number example number 2. It's the same rule, you just copy it. Find the derivative of ln sine x. Okay, the derivative of ln sine x, again, it will fall on this rule. 1 over the function, okay, 1 over the function, our function is sine x, 1 over the function, sine x, times the derivative of this function. Derivative of this function, derivative of sine x is cosine x. So cosine times 1 is cosine over sine x. Cosine over sine is cotangent x. Alright, final answer is cotangent x. Okay, example number 3. Find the derivative of log x base 4. So I think it will fall here, here, this rule. Log x base 4. So the derivative of log x base 4 is simply 1 over x, since our function is x, 1 over x, here, 1 over x, over ln of 4. This 4 is our base. So the final answer is 1 over x ln of 4, ln of 4. And we have example number 4. Find the derivative of log x squared plus 7x base 5. Okay, so the derivative of log x squared plus 7x base 5 is simply 1. So this problem falls on this rule. Okay, 1 over the function, and our function is x squared plus 7x. 1 over the function, ln of a. Our base is 5. So 1 over the function, ln of 5, derivative of the function. So the derivative of the function here, derivative of x squared plus 7x. That gives you 2x plus 7. So 2x plus 7 times 1 is 2x plus 7 over x squared plus 7x ln of 5. So this is our answer. So that's all for the differentiation rules. Thank you for listening, and I hope you learned from this lesson. Good luck, everyone. Bye.